Yesterday you did problems involving probability and the word exactly. So today we're going to look at something a little bit different. It's very similar to exactly, just kind of an extension of it. So we look at this question here. It says Rose is competing in a free throw contest in basketball. To win, she must be successful in at least 4 out of 5 throws. If the probability she'll be successful is 3/4, what's the probability she'll win the contest? All right, now, the one thing we need to look at here is this phrase right here that says at least. When we see that phrase at least, that means that there's more than one possibility. Now, to win, she has to be successful in at least 4 out of the 5 throws. That means she can make one of 2 things. She can make 4 throws and she wins the contest, or she could make all 5 and she still wins the contest. So because we have 2 options here, this is what I'm talking about when I say it's an extension of the exactly. So we're going to set it up very similarly. So let's just look at the 4 throws for a second. So she would be shooting 5 baskets, but out of those 5, she'd get 4 of them. Okay? Then the probability that she will get a basket is right here. That's 3/4 times, now remember, what goes in the second set of parentheses has to add up to give you a whole. So 3/4 plus 1/4 is a whole. And same rule as what we did yesterday with exactly, where whatever number is to the right of the C will be your first power. And then your second power will be the number to the left minus the number to the right. So that would be a 1. Okay, so set up exactly like exactly. Haha. All right, now or, the only difference is or is going to mean that we add. So we have another scenario that also works as well, and we will just add those answers. So now if she has a total of 5 throws possible, and of those 5 throws, she gets all 5 of them in, that would be 5C5. Now it's the same probability. The probability she'll get a basket is 3/4. The probability that she won't is 1/4. Again, remember those numbers need to add up to one whole. All right, now the number that's to the right of the C is your first set of parentheses, is your first exponent, and then your second exponent will be the 5 on the left minus the 5 on the right, which would be 0. So you see it's exactly like yesterday. Now you just get to do the work twice. Lucky you. So 5C4 we would put in our calculator and we would get 5. 3/4 to the 4th power, so that would be 81 over 256. And then we've got 1/4 to the 1 power, which is obviously 1/4. And then over here we have 5C5, that's 1. And then we have 3/4 to the 5th, which would be 243 over 1024. And anything to the 0 power we know is a 1. So then we're just simply going to work this all out. That would be 405 over 1024 plus 243 over 1024. And then we would add that up. That would be 648 over 1024. And like all probability, there really is no need for you to simplify that fraction. So we're done. Now, so what I want you to see is when we have that phrase at least, notice we start with the number to the right of that phrase at least. Look at what I'm circling in red. So notice here we started with a 4, and then after that, look at this number here, we work our way up. Think about it in terms of if I have at least $4 in my pocket, that means I have $4 or I can have more. In this case, I can have 4 baskets or I can have more. Now the highest I can go to is 5 baskets because the free throw contest is just 5 throws altogether. Okay, so if it was 7 throws, we would do 7C4 plus 7C5 plus 7C6 plus 7C7. We always go to the number on the left and the right, if we look right here, are the same. So notice that both this number here and this number here are the same. So we just would keep on going. Let's look at the next question. All right, so Joe's tossing a coin 6 times. What's the probability he will get a tails at most 2 times? Think again in terms of money. If I have at most $2 in my pocket, that means I have $2 or I actually have less. So in this case, we're going to go in the opposite direction. So he has, he's tossing the coin a total of 6 times, but he wants to get at most 2 of them to be tails. So he could get a tails twice. I'm going to leave some space. He could get a tails once, or he doesn't even have to get a tails at all. So those are our 2 scenarios. Now the probability of getting a tails is obviously a half on a coin, and the probability of not getting a tails is a half. So all of these will be a half. Okay, remember those 2 fractions need to add up to a whole. Oops, and I'm going to be squeezing it in down here. Sorry about that. All right, so everything else is exactly the same. So the first exponent will be a 2. The second exponent we subtract. The first exponent here will be a 1. The second exponent we subtract. Over here, this is going to be a little messy, I apologize. The first exponent is going to be a 0. The second exponent we subtract. That's a 6. And then again, we just do all the math. So we've got 15 times 1/4 times 1/16 plus 6 times 1/2 times 32. 1 over 32, my apologies, plus 1 times 1 times 1 over 64. Okay, so then we've got 15 over 64 plus 6 over 64 plus 1 over 64, which is 22 over 64. And there would be our answer. Again, no need for you to go any further with that and simplify that. Alrighty, so let's just kind of wrap this up. If you see the phrase at most, remember that phrase means that amount or less. So you would have that amount or less. In this case, Joe tossing a coin 6 times. At most 2, you would do 62, 61, 60. If you see the phrase at least, you're going to do the opposite. So at least would be that amount or more. Again, think of the amount of money in my pocket. If I have $4 or more, I have $4, or I have more than that. I could have 5, I could have 6, whatever. Okay, so for example, let's just take this Joe is tossing a coin 6 times scenario here. If that phrase, instead of saying at most 2 times, said at least 2 times, you would be doing 62, then 63, then 64, then 65, then 66. And obviously all the fractions and exponents that go along with it. So at least you keep on going till the number on the left and the right are the same number. In this case, like I said, if this Joe tossing a coin was at least 2 times, we'd be going all the way from 62 all the way up to 66. At most, we would start at 62 and we would work our way down until we got to 60. So at most we want to work our way down till we get to that number C0, and at least again we want to work our way up to the number on the left and the right of the C are the same.